we did here. Chapter 6 is, well, let's see. Chapter 6 was about probability distribution, 6.1, and 6.2 was about the discrete version, which was binomial. Now, when you get to chapter 4, that's chapter 6.4 and 6.5, it's about the normal. So everything else going forwards, just about everything, not everything, but just about for the rest of the semester is about normality, bell-shaped curve. So this is called the standard normal. Standard normal would be where the mean, which is found in the middle of the bell, is always 0. And the standard deviation, mu, is always 1. And so what we ended up doing is having, it's kind of hard to see, but you can see the 0 there, and then add 1, add 1, add 1. There's a 3 there and a 4. And you go this way with negative. So you're looking at capital P as probability. And these are z-scores. So standard normal or z-scores, where regular normal, you'll see today in 6.5, would be x values like raw data, or x, like the amount of time someone owns a TV at Costco and they want to trade it in or buy a new one. X is the amount of time in like years. So then the markers down here would be the real data instead of 0, 1, 2, and 3. You'll have the real data. So we were just looking at the standard normal here, and you would always have a cookie cutter 0 to up to 4. Really all you need is up to 3, because anything beyond that is an outlier. But you know, these pictures I got from the internet, so they went up to 4 and down to -4. And what you do is you find these values, these z-score values, which I found here, and did the shading between. And the shaded region is called the probability. It's the area under the curve above the x-axis. And we're not doing a table, we just did the calculator. And so it's pretty user-friendly, pretty easy. Just as long as you know how to use the calculator, it's pretty easy. So this one I didn't do. Might as well go ahead and do it now. So no table, I want to do the right. So you go probability that the z-score is to the right. So we'd say no equal sign. It doesn't matter as the answer, but just no equal sign. It doesn't matter. But if I was grading on process, which the group quiz I will, and if to the right you interpret it with the equal sign, that's not to the right, that's to the right and including. It didn't say including. So on the group quiz, I could take a point off because your interpretation is wrong, but the answer that you would get with your calculator would be identically the same. It wouldn't make a difference. So that's the right symbol to the right. That's the correct symbol to the right. And then that would be -2.7. And go over here, it's about right there. That's about -2.7. Dot, 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 we kind of talked about that. Hard to put a bunch of dots in there. Dot, 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 because there's no equal sign, that would be a solid line. And shaded to the right. And I just look at that and I say, hey, I know that answer is going to be more than 50%. I know it is, because halfway is 50%. That's more. So how do we find the answer? Well, let's see. We go normal, NOR, normal, CDF, CDF. And then we do left, right, or lower, upper. Left, right, lower, upper. I think the calculator says lower, upper. Left here is -2.7. Right is all the way out here forever to infinity. So just pick something big, ridiculous, like 1,000. That's ridiculous. That's way farther than 4. Comma. Then you pick the mu, which is 0, This is your mu. And then you pick your sigma, which is 1. That's your sigma. And then squiggle, squiggle. And it's always 4 decimals. 4 decimal places. So your calculator go here. And you go second distribution again. Yeah, it's the CDF, not the PDF. Okay, the TI-84 doesn't set it up this way. Eventually you cut and paste it. But really the lower is this. This is your lower, lower. This is your upper, lower, upper. All right, 10,000. All right, 100,000. It doesn't matter, just something big. And mu, okay, good, good. Paste. Okay, see now it's pasting it like it's supposed to look like here. TI-83s will have to put these numbers in with commas. See, there's the normal CDF, just like I've listed it out here. Okay, now I just hit enter and okay, 0.9965, 0.9965. 0.9965. Or about 99.65%. Decimals fine, percent's okay. If it's a test, just, you know, it'll be obvious whether it's percent or decimal. Most of the time it's decimal. Most of the time it's decimal. And that's what 6.4 for the most part was all about.
And this is inclusive, or?
No, it's not inclusive. Didn't say inclusive. Doesn't say inclusive. Doesn't say that. Your homework,
Okay.
a few problems in your homework does say inclusive. And so if it says inclusive, then you put an equal sign.
Greater than or equal to, yeah. Okay.
But the right does not interpret as inclusive. To the right means to the right, not including. Yeah, the language of mathematics with English.
Hey, Jeff.
Not an easy thing for some of us.
Hey, Jeff.
Sure. Enrique? Sure.
Yeah, sorry about that. Quick question on the same problem. If it were to say, look for the left, or was that left that we just did? Yeah, right. So if it did left, would we pretty much plop over the upper and lower opposite on the calculator, if that makes sense? So in that problem, it was asking to the right of negative 2.7, which would make the lower negative 2.7. But if it was asking for the left, would the upper then be negative 1,000 and the lower be negative 2.7?
Yes.
Okay, cool.
Is that what you just said?
Yeah, exactly. Thank you.
Yep. You're welcome. Which would be almost 0. That's the complement, isn't it?
Yeah, pretty close.
The answer would be that little itty bitty piece right there that's unshaded, which would be 100% minus that. So it's not a lot. All right, this one here, you go probability that Z is in between. Now, I've said before, in between inclusive, boy, that really tells me that it's got an equal sign. Just in between, it feels like it's not inclusive. It feels like it. So I'm going to do that. I'm not going to be picky about in between on the group quiz. If you put the equal sign, I'll take it. If you don't, then I'll take it, of course. But to the right and to the left, oh boy, those do not have equal signs on them. So let's see, there's -1. Oh, right here. Okay, there's -1. Not. And 2.13 right here. So this is -1 here. Lower is -1, upper is 2.13. Remember rounding, 1, 2, 3, 4, look next door. That's a 5 or bigger, make that an 8 then. Yeah, no table, no table, no table. Okay, probability to the right of that. Okay, probability that the z-score is to the right of 2.56. 2.56 is right there-ish. Yeah, it's not very much. Yeah, the answer to that's not very much. Probably is going to be about 0-ish. Big, make it big. Yeah, not very much. So hopefully you get the idea, or you're reminded about the idea. So whenever you got around to doing your homework, the theory was last Monday your homework would have been done. But then the fires happened. And then a lot of stuff, life was kind of chaotic. So in theory, the homework's already been done. But you had some extra time to kind of polish it up wherever your life kind of, some of you maybe were displaced. Some of you, I've already had 2 students said they lost their home, lost their homes. And that one student that actually emailed me, I said, we'll figure it out. Let me know how I can help. So if anybody else is in that circumstance, let me know what's happening. If there's something that I can do or help, let me know the circumstances and we'll work through that. But the rest of us, we're either back in our homes or we're getting close. You have access to your material, and now your exam is put off for a week. Should be enough time to get back into a routine. Okay, let's see anything else. We did those. And there were others, but I don't think I need to do these because you just like them. You just have to draw the bell-shaped curve, on this one here. I'll do this one. This will put a smile on my face. Watch this one. Okay, there's mu, which is 0. I have to go out to 11? Yeah, way out here. Yeah, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. Okay, shade. I don't even have to use my calculator to know what the answer to this is. I'm not, it's like squiggle. Without my calculator, it's 1. It's everything. It's about 1. So what about this one? You think that's about 1? It's not as far as 11, but wouldn't that be also 1? Anything beyond 3 standard deviations and you shade it to the left, yeah, it should be close to 1. So that one also be close to 1. Anyway, you can work on those yourself. And
Wait, sorry, Jeff. Which one is close to 1?
say it one more
4 or
time.
2? Which one was close to 1?
What, this one?
Other than that one.
This
You're
one?
pointing at another one. The number
This-
4. Okay. That was it. Yeah. Thank
Calculator on this one. Oh, okay. Lower, ridiculous, negative a bazillion here. Like, that's really far. Here, I'll show you again. Negative, like that. Upper, well, that's going to be the upper. Yeah, really close to 1. Really close. Not quite, but really close. So 6.5. So the difference in 6.5, we're going to be looking at pictures that are and answering questions about real data rather than using the standard normal. And standard normal is probably for you guys in this course. If we had a table, it was a way that everybody, you know, if they were stuck, they didn't have the calculator with them, but they had a table somehow. Everybody has access to a table, or converting raw data into z-scores and using a table. You don't have to worry about the table. It's just use your calculator. Yes, you remember this, that converts raw data into z-scores. But for all the homework problems, you don't have to convert them into standard or z-scores. Don't need to do that. So I'm just going to show you with raw data how to draw the picture and use your technology to answer the question. So really, this right here, you don't need this because I'm not using the formula. Not doing that. Not doing that. So what are you doing, Jeff? Well, I'm just going to look back at, gosh, it sounds like we've done the TV problem before, haven't we? Sounds like, I don't know. Let me look. Sounds like we've done the TV problem before. Just feels familiar. Oh my gosh, we did. TV problems. All of these. How did we do these before? We looked at the pictures, you know, the shaded regions. Remember that? And going back here to number, this one here. What did we do? We had all these 34, these are percents, by the way. You remember that. So I just took 50% and subtracted off what I didn't want. That left me what I, like right here, there's your answer. But with the calculator right here, you'll see with all the other problems that I'll do today, all you have to know is second, isn't normal. Yes, it is, because it said it was normal. Here, normal. So it's normal. Okay, what's my lower on this? Well, it looks like it's 6.6. See, remember the more than? There's some phrases, does not include the equal sign. Yeah, more than. So I'm going to go here, 6.6. And then to the right, okay, come up with something to the right, like ridiculous, like a bazillion, like maybe 10,000. Now this is going to be the difference. Mu is not 0. Mu is right there, 4.8. Mu is 4.8. And standard deviation, usually it's given to you. Somebody gives it to you. Okay, there it is right there. Then you paste, hit enter. Yep, look at that, same answer. Pretty close, same answer. So that's what you got to do. We'll draw pictures. We're going to do the shading thing. For the group quiz, that's what I'm going to ask. You're going to have to draw a picture for the group quiz. You're going to have to put the markers down like I'm doing right here for the group quiz. I'll require that. You're going to do the shading. I require that. And then come up with your probability based on your calculator. Now on the exam, all you're doing is enough to answer the question hopefully correctly. That's all you're doing for the exam. Give me the right answer. So I won't be looking at the process. So let's go to 6.5 and see what I'm doing. Oh, back here. It's saying that television one again. Oh, fine. All right. So we're going to go like bell-shaped curve. So this is something like the group quiz that I would be expecting if this was a group quiz questions. And you put the marker right here, which is your mu. This is your mu. So 4.8. And how many markers to the right? All you need is 3. How many markers to the left? Same thing. Sigma, there it is, sigma's here. So add 0.9 to this. Okay, what are we doing? Okay, survey said that people keep the TV sets on average 4.8 years. Oh, really? Yeah, how do they know that? Well, they took a survey and they gathered a bunch of data. And they put it in their calculator, let's say, and did a 1 var stat and came up with 0.9. And they're telling you what it is from their calculator. Oh, okay, I get to use 0.9. So add 0.9 to this, that would be 6.6, and add 0.9 to this is 7.5. Subtract 0.9, 3.9, 3, and 2.1. Okay, find the probability. So you go capital P. I'll expect this as well in the group quiz. Make the mathematical symbolic statement, find the probability that, okay, and then you're going to use X. X is for the raw data, Z is for the standard normal. Has own less than, no equal sign, 2.5 years. Squiggle, squiggle. No, 2.5 years. Well, that's over here. So like right about in here. Okay, now my lower. Lower goes all the way, starts way over here to the left, way over here. Now, negative 100 would probably be completely enough to the left. If you want to make it more zeros, then go ahead. Okay, upper. Now, that's the right. Stops right there at 2.5. Okay, mu. Sure, 4.8. There's my mu right here. Sigma, paste, answer, about. 4 decimal places, 0.0053. What's the problem? Okay, the question is, um, what's the likelihood that a randomly selected person at Costco tomorrow, any randomly selected person would say that they owned the TV set that they're replacing, previous one. They owned it between 3 and 4 years. That's what they're replacing. And that's what you're looking for, the probability that's going to happen, which is going to be less than a 50% chance. So let's see, we do this. Okay, there's a 16% chance. The probability that's going to happen is 16%.
Hey Jeff, how did you find the z-score for the bell-shaped curve?
What's the z-score? We're not in the z-scores. That's 6.4.
Well, right, okay, but my question is like, how do you get like for example on B you have 2.13, 3.9, 4 point, looks like 8, 5.7, 6.6. Oh, okay. So it's standard deviation of mu.
You start there in the middle, and then you're always adding. So this would here, you get this by taking 4.8 plus 0.9 equals that.
Got you, okay. Perfect. Yeah, I just missed that clearly. I don't have it printed off. I'm trying to print it off now. All right, thanks.
Sure. And more than 5 years, so then you go bell-shaped curve again. Oh, how did we get that? So this right here comes from, you got 4.8 subtract a standard deviation. So this would be 5.7, 6.6, 7.5, more than, probability that X is more than, no equal sign. So here's your 5, almost 50%. Okay, now the lower is right here at 5. So I go up at 5. The upper is anything that's to the right, way over here. Anything to the right. Like 100 or 1,000 or 100,000. Hey, how about 100,000? Sure. And then everything else is the same. It's the same problem. So it's about 0.41, what, 21? Less than 50%. So, yeah, okay, kind of makes sense that it would be that possible number. So all the word problems that you see in your textbook, most all of them, if they say find the probability, it's got to be assumed to be normal. That's the first thing, and it will say that. Earth weights are normally distributed. Okay, so it says normal bell-shaped curve then. They're saying that the average weight of a newborn would be that many grams, and historically, or they gathered all the data in a database, they're finding out that the standard deviation is 500 grams, and they're asking for a probability. So you're going to draw bell-shaped curves, put the markers in, and use your calculator. Come up with the area. Let's see, what else? Oh, we want 6.5, don't we? My mistake. Pardon me. Pardon me. 6.5, Jeff. Yeah, okay. Okay. Try this again. Okay, this is 6.5. They just say mu is 70. So draw a bell-shaped curve with 70 in the middle. Standard deviation is 10. Well, that's convenient. So you go 70, 80, 90, 100, and then 60, 50, 40. And then you'll find that, find the marker, use your calculator to come up with the answer, and you're done. When it says standardize, don't do that. You don't need to do that. You see it says standardizing to Z? You don't need to do that. You could if you wanted to, but you don't need to. Try that again. Okay, there's the, it focused. 6-week-old babies consume an average of 15 ounces per day, with the standard deviation of 2 ounces per day. Assume it's normal. Okay, we get to use a bell-shaped curve. Find the probability that the chosen, that A randomly, okay, how many babies does it mean A randomly chosen baby? Give me a number. How many total?
1.
Right. That's going to be going forward in chapter 7. They're going to say, like, find the probability that 3 randomly chosen babies. That's different than a randomly chosen. It's key. It'll be key in chapter 7. So I'll come back to it when it says, a randomly chosen is the number 1. Sample size is 1. N equals 1 for these. In chapter 7, it'll be N equals something other than 1. All right. Okay. Less than, more than, between. Yeah. Don't turn them into standard scores. Just do the bell-shaped curve. And 34. Oh, okay. Facebook friends. They reported, let's see, 2014, that the average number of Facebook friends for 18 to 24-year-olds, the average number was, that's your mu, 649 friends. Assume this distribution is normal. Okay, so mu is 649. Standard deviation is 150 friends. So draw the bell-shaped curve, put your markers in, add and subtract 150 left and right. Find the probability. Okay, fewer, no equal sign, that's less than. More than, no equal sign, that's a greater than. Between, okay, fine. Okay, now this is something new. I'm going to be going over this today, the idea about percentile. We did percentile concepts back in chapter 3. So we're going to do some problems about percentiles. Also, this stuff right here, like number 35, I have to go over that with you as well on how to approach those problems. So there's 2 new things. It's called the percentile, like here's percentile. How do you find those? And when it calculates this right here, how do you do that? Like number 37 is a good example of something that's new. Oh, and look at the pictures right here. If I have time, I'll address these pictures and what the heck those things are. Okay, let's see. Yeah, this is just more pictures. This is nothing interesting. It's just same stuff. So I'm not going to do that. All right, now this formula, I'm just going to step through it with you, show you kind of how the result down here came to be, because you'll need to use this possibly, or use something in your calculator called inverse norm. Inverse norm. I'll come back to that in a moment. Okay, so we remember that formula. Yeah, no problem. This is an equation. So the algebra would be the following if I want to get the x by itself. If I want to get the x by itself, how do you get rid of the sigma in the denominator? You multiply both sides by the denominator, by the LCD. So when I do that, there it is, multiply both sides by the LCD, a little bit of algebra right there. Then you get this result. How do I move that mu to the other side? You're going to add mu to both sides, algebra again. So that's what I'm showing you right here. So then you get your x all by itself. This is the same as this. Now, what's the big deal right there? X is called, sometimes we call this so when asked for the percentile, that's going to have something to do with it. This formula, x equals, has something to do with this result. To remind you about percentiles, percentile is a position, measure of a position. You line if you had raw data, which you won't have raw data, but if you had raw data, you line it all up in ascending order, and somehow you have to count. Remember the I, the little formula in percentiles, that I equals, what was it? N divided by 100. Let's see, what was it? N divided by 100. I think that's what it was. Times P. Gosh, little p. No, that's not right. Had it almost right. I equals percentiles. Oh, I know what it was. P over 100. That's where it is. Times N. That's what it was. And you always round up. That's chapter 3. And then you counted. So the I was not the answer to the percentiles, even though some of you were answering it that way. That's not right. I helped you identify, and it was a number, identify which raw data was considered the, say, the 75th percentile. And X is called the raw data. So how to find the X value, the percentile number, you do this formula. Now, you will be given sigma and mu. You will be given that. You won't be given the Z. And the only way that you could find the Z is with the table, and I never taught you the table. Never taught you the table. So you got to have another way of doing it. I'm going to go into your textbook and reference 6.5. Okay, so I'm on page, if you're referencing this in your notes, I'm on page 372 in your textbook, page 372 in your textbook. Suppose students in the top 1%. Okay, we're back to the SAT scores, which I've done a couple times in the past. The top, wouldn't that be to the right? The top. If I look at the number line over here, the top would be to the right. That's true. And 1% is the same as decimal 0.01. So the top 1% of SATs won a fellowship to the Ivy League university. What is the score? Okay, so they're looking for an X value score. Now that's the same as percentile in a way. You'll find out percentiles are always, for you guys, the probability below the marker. So percentiles are always the region to the left of the marker you're looking for. This region I'm shading right there is to the right. If that's 1%, how much is below? Or I'm pointing to it right there. I didn't realize it was there. 99% is below. The X value you're looking for, which is that right there, that number on the number line, is gotta be more than 514. That number's to the right. It's gotta be more than 514. That's called, that number you're looking for is called the 99th percentile. That X that you're trying to find is called the 99th percentile. Percentiles are always shaded to the left. So, how do you find it? Well, two ways. You have either formula that looks like this. There's your formula. But you have to have tables in order to come up with the z-score. So I'm not going to show it to you that way. I'm going to show you with the calculator how to use the calculator to find the result. So what did they do here? Let's see if they use the formula of the calculator. Okay, so they drew the bell-shaped curve. They put the marker 514 right here. They knew that the top 1% was in the tail up here. There's a little X value that you're trying to find. You're trying to find that X value, X of 1. And I am going to look at step 2. Step 2, they said find the Z value for the corresponding area. Now, that says you look it up in the table. Not doing it. Not doing that. So step 2 is not helpful because step 3 is not helpful either because you need the Z. You don't know that. So what do we do, Jeff? Going to show you here in a moment. Here's something else on the next example. Average amount. Okay, so they tell you what the average amount, that's your mu. And there's your standard deviation. So you draw a bell-shaped curve. Now for us, our bell-shaped curve will definitely have 28,000 in the middle, but you're gonna have additional markers on all these problems to the right and to the left. And you're gonna have 3 markers to the right and 3 markers to the left. You're gonna be very detailed for me on your homework and your group quiz. This is not detailed. No, they didn't do a very good job, not the way I want you to do it. Now what they're saying is find the price that separates the middle 95%. Okay, so the middle 95% is the green shaded region. You got to find a price that's higher and a price that's lower than the average price of here, which looks like they're talking about the cost of Camrys, Toyota Camrys. And they said the bottom 2%, 2.5%, and the top 2.5%. The bottom 2.5% is down there, and the top 2.5% is right there. So the leftover, okay, think of it. 2.5 plus 2.5 is 5%. The leftover is 95% in the middle.
So that's the 95 percentile, right?
No. Percentile is always the incomplete shaded region to the left. So if I wanted to find and talk about that, including that would have to be green to be considered a percentile. Then that marker would represent 95 plus 2.5. That marker right there, x of 2, would be the 97.5 percentile.
Okay, thank you.
If this white region was shaded, and you want to look at what percentile language, how do you put that in a percentile language? For x of 1, that would be 2.5 percentiles. Kind of weird. Like the third percentile. Okay, the 2.5 percentile. This problem is talking about middle, the middle, 95%. And the question is, how do you find the x of 1 and x of 2? You got two pieces, so you have to do them separately. And again, you can't use your tables because I'm not teaching that to you, so you have to have another way of doing it, which is going to be your calculator. And I've yet to show you that. But these are two standard kinds of problems in your homework, and also ones that I could give you on the group quiz as well as the exam. So they would talk about the middle. Here that says find the prices, separate the middle. Oh, there it is, middle 95%. That's a pretty common problem that you'll find in your homework. The other common problem would be what's called percentile. And I'm looking here on the previous problem, they don't say percentile. They do it over here on these homework problems. Find the number of Facebook users, find the X value. That represents, where am I? Right here, the 75th percentile. Okay, that's a common phrase. So I got to show you how to do something like that. The other one would be something like this. Find two symmetric, okay, symmetric. That means they look identical to the middle. The middle's right here. The one on the left, the one on the right, same distance, symmetric. And notice it's called central 98%. Central. The central 9, that's like the middle 90%, the middle 98%. So that's the kind of problem that your textbook was just doing in their example that you'll get for your homework. Now, in my packet, I have an illustration, I think, of both of them. So don't look at the instructions here. Don't look at that. I'm going to show you how to do it and use your calculator. So I'm just going to draw a bigger bell-shaped curve like this. Bigger bell-shaped curve. Okay, you draw this right here in the middle. It looks like the average is $8,256. Auto dealer finds that the average price of the previously owned vehicles is $8,256. Decides to sell cars that appeals to the middle 60%. Middle 60%. That means you're going to go 1, 2, 3, 1, 2, 3. This is going to be 8256, and each one of these markers, let's see right here, the standard deviation, $1,150. So this one here is going to take the $8,256 and add $1,150 to get you, I can't do that in my head. $9,406. Okay, so this is money. 9,406. This one here is going to take that number 9,406 and add another 1,150. 9,406, add another 1,150. Okay, so this is 10,556, and finally that one there. So now I go backwards. I take the 8,256, 8,256, and you'll subtract a standard deviation. Subtract one of these. Do it again. And one more time. Now, I don't need to go any farther because beyond that, they're outliers. So just for us, for the picture, you just need to go 3 to the right and 3 to the left. Now, with my red pen, I'm going to figure out about where the middle 60, okay, the middle 60%-ish, the middle 60%. From a previous section in your textbook, you remember, I'm reminding you that you had pictures that showed percentages. All right, fine, I'll show you where. Way back, way back. Okay, I think it was even, what is that far back actually? 6.4, yeah. Oh, here. So between the first markers, that's 68%-ish. About 60, I don't want quite that much. So between the first markers, that's 68%. I want to go in a little bit, like right about here and right about there. About. I'm going to find them exactly in a moment, but that's about 60%. This right here is about 60%. Not 68% because they're in a little bit. So this first marker right here is your first X. This one here is your second X. Now, I'm going to put in here, let's see, yes, I got orange. I don't know if orange, oh, I'll do purple. I'll do purple. Probably not going to come out to be any big deal about a color. All right, 60%'s there. How much is left over out of 100? 40. I'll say it again. 60's here, 40's left over, 20's for here, 20's for there. This is 20% here. This is 20% here. So altogether, it's 100%. Now, this would be considered the 20th percentile. It's always to the left. The percentile percentage is always to the left. So 20th percentile is that marker. It's that X value. And X of 2, the 80th percentile. Remember our notation? Capital P is percentile. Capital P, the 80th percentile. Now I just have to figure out how to use the darn calculator to come up with the answer. So back to the textbook. Okay, I see it here. Okay, if you're referencing a page number, it's 375. Page 375, if you're referencing a page number using technology. TI 8384. Okay, let's see. That's like the 99th percentile right here. So see this right here where it says inverse norm? It's in your calculator. I'll show you where to find it. Inverse norm. Look at the numbers they're putting in. That's the percentile, 99th percentile. Okay, what's that 0.2872? I know hold on a second. Let me see if this was 1, 2. That looks like a 0. Oh, it is a 0. That's the mean. Look at that. 28,720 is the mean from over here. So it looks like there's 3 numbers we're going to have to try to find. The percentile, which you just turned it into a to a decimal. The mean, and that's probably the standard deviation, the 1,000. It's probably the standard deviation. I'm looking to see if this problem just before it, if it says it's probably the standard deviation. Going back, oh yeah, okay, here it is, the previous page, thousands. So in your inverse norm, and your instructions are back over here at the back of the page as well. Your instructions are back here. Look at page 380. If you're wanting to find the areas of probability, okay, let's see what are we finding percentiles. There it is right here. Inverse norm, that's what you're choosing. Enter the probability value, comma, enter the mean, comma, enter the standard deviation, comma, no comma, sorry, close your parentheses and hit enter. That was page 380. So to find this one, to find x01, I'm going to turn on the calculator. It's going to be second distribution. There it is, number 3. You see where it says inverse norm? Number 3. Now mine's a TI-84 plus, and it asks it slightly different than the way that they show it in your textbook for the TI-83. I said TI-83 plus. Mine's a TI-84 plus. So the area is the percentile or the percentage. I want 20. Don't put it as a percentage. You got to put it as a decimal. Mu. Oh, 8256. Sigma, 1150. Paste. Enter. This is money. This is money. So this this value right here is dollar amount $7,288.14. This value, car-wise, I do the same thing, but it's going to be the 80th percentile, so do it over again. 80th percent, so 0.8, but I think everything else remains the same. So this one here is $9,223.87. So the question was, not the question, it says find the maximum and minimum price of the cars the dealer wants to sell or will sell. The dealer is going to sell between these two dollar amounts for used cars because he wants to appeal to the 60% of the car buyers out there. Because he can't have all the cars on the lot. They don't have enough room nor enough money. Inverse normal. Inverse norm, that's what you're using. And I think I gave you 2 page numbers in 6.5 to refer to. All right, let's see. Now I want the 99th percentile. The shading is always to the left. I need 99% probability to the left. Let's see, that's 50% right here. That's more. Oh gosh, it's got to be way over here somewhere, doesn't it? I'm going to shade to the left 99%. I'm going to find P of 99 equals, oh, okay, so somewhere, I don't know, maybe right here, question mark. That's the question, is where do I put it? Well, I think I'll put it right here and call that X of 1. So what I'm going to do is I'll find out exactly where it is when I do inverse norm. Second distribution, inverse norm, oh, 0.99. Ten, 9, 3, 1. Okay, I'm on the wrong side of this number. You see that? 10, 9, 3, 1 should be over here. So my marker is not on the correct side. So I'm going to erase that. Erase it. That's funny. I'm going to wipe that sucker out right there. This should be over here. So this would be 10,931 and 30 cents. I'm not going to do the other one because it's the same thing. The 10th percentile would be shaded down here though, somewhere. The 10th percentile. So if I want to know about 99th percentile, this right here is 99%. Okay, the last thing that I've got for you in 6.5 is that you had a couple pictures that I showed you with the homework that had these dots in there. And like these guys. Again, on 6.5, this is page 383. So you got what the heck is going on there? If it doesn't say normal, if the problem going forward, not all the problems are going to say normal. You have to figure out whether or not it's normal. This is a graph, and I'm going to be showing you in the future how to come up with that dot plot. You'll never get the orange things. That it never comes up in your calculator. You just get a bunch of dots. you have to have the raw data in order to create the little dot plot. So right now we're not going to have the raw data, but the picture indicates that if it's like this one here, it's not normal. How come it's not normal, Jeff? Because it's too curvy. See how some of the dots are outside the orange curves? This is not normal. This one would be considered normal because it's bound, all the dots are within the outside orange curves. This one looks normal because it's bound between the two curves. This other one does not look normal because you've got some dots that are outside and you got a little something outside the curve. So just by the pictures, which ones are normal, which ones are not, the ones with the pictures that it's within the orange, normal. They say approximately normal. Give me a moment. What are you going to do about that? Sure, where are you going? I'm looking at your homework problems. I'm going to dog ear this because we will come back to it. The only problems I may have given you are those 4 graphs. And that's the only way that you know how to decide whether it's normal or not, if it's bound within those orange curves. That's it. But later on, chapter 7, 8, 9, and 10, you're going to have to figure out with raw data whether it's normal. And this would be the set of instructions to graph it. It's also in your textbook. So basically, I'm done. The only thing about those dot plots are from your textbook, the 4 graphs. That's it. We'll use it later on in the course. So what's 6.5 about? It's the word problems. Can you find the probability with the word problems using normal CDF? Can you find the percentile questions using inverse normal? That's it. That's 6.5. Now, I'm looking at the time. With the time that's left, there'll be some questions on your little baby quiz with regards to 6.4, which is on the Z-scores that I introduced you or reminded you about at the beginning of class today, 6.4. And then when you're done with that, that's all I have for you. And I will be out here waiting for anybody who has some specific homework questions. I'll stick around for that as well. Any question before well, I gotta turn on your quiz. Well, number 6. Let's see, number 6. Don't have that yet. Okay, I'm still looking, still getting ready to. Math 15, yeah, Oh yeah, I can see that. I just didn't have it uploaded. Give me a second here. I've got to stick them in. Your PDF, your PDF's not there yet. It'll take me 60 seconds to put it in. Quiz number 6. Here, number 6. Number 6, no answers. Okay. There's only 4 problems. 6, yeah. Okay, see if you guys go into Canvas and see if you see daily quiz number 6 PDF there. I just need a couple of you to say, I found it. Okay, Richard's saying yes. Thanks, Giselle. Okay, so daily quiz number 6. You open up the PDF. There's 4 questions. The answers are in Canvas. And I'll put you in groups of 3 or 4. Okay, 3 or 4. Okay, I'll be here if you need my help or afterwards. So Simon, did you find it yourself? Ray, Jonathan, you guys find the daily quiz number 6?
Yes.
Okay. Frank, how about you? Did you find it? Okay, good. And there should be a breakout room number that's assigned to you. There you go. And then Simon, did you find out your great, your room looks like Simon, I don't know if you're there. You're number 6, Simon.